Hello everyone, my name is Mo Sani and I'm one of the solutions engineers at Edge Impulse. In this video, I have a really exciting product to talk about. I'm really excited to announce the support for this triple vision industrial AI camera. In this video, we are going to unbox this together and connect it to Edge Impulse and see how we can collect some data and quickly build a machine learning model and deploy it back to this product. Actually, we're not going to do it once, we're going to do it 3 times to have 3 different models running in parallel on this machine. Let me tell you why I'm very excited about this product. This is running on Qualcomm's Dragonwing QCS6490 platform, and it has 12 TOPS of AI powers, and it comes in a really nice rugged boxed environment in a box which is waterproof and ready for industrial integration. It has 3 12 megapixel cameras. Again, they're in industrial format, ready to use, and it comes in Android or Linux format with operating system. I'm going to talk about mainly about the Linux one, and a lot of other features as well. It is a perfect platform for industrial visual inspection solutions, object detection, anomaly detection. You know, your packaging, your production line, you want to install not only one but multiple cameras in your conveyor belt to detect anomalies or detect defects in your quality control, or in the outdoor environment you wanted to detect objects, or in car parks you want to look at the scene and infer something. Generally, in any use case that you want to run good high quality AI models on the device on multiple cameras, this is the platform to choose. Now, let's go do the unboxing and we can see why I'm very excited about this product. Start unboxing this. Okay, now let's go and unbox this exciting product. Triple Vision Industrial AI camera made by JMO and distributed by Codico. It is fully supported by Edge Impulse platform and it's running on Qualcomm's Dragonwing. Are you ready? Okay. There you go. This is coming with an instruction set, and you have 3 cameras with their lenses. You have this AI box that inside you can have, well, inside of this you have the QCS6490 Dragonwing. It comes in a really nice package. It's waterproof IP66, and as you can see here, you have the mounts for now these are the camera mounts. You have the DP port, 3 DP ports that you can connect your cameras, and here you have the Ethernet port, you have the HDMI port, and you have the USB-C that you could connect your keyboard or mouse or anything you wanted. And here you have the power and power button, and this button is used for flashing the software or putting it into the bootloader mode. It feels really good and solid. And yeah, it has some mounts here if you wanted to mount it somewhere. So that's that. Let's go have a look at the cameras. Okay, so it comes with 3 12 megapixel cameras. Really nice and high quality. They have adjustable focal length, so you could adjust them in two different, I think one of them is the, yeah, I actually have to check the specs. What are the mean and maximum focal length for these? And of course you could change these as well if you wanted. And here you can see the Sony lens. Put this back. Again, DisplayPort. You have 3 of that. You get some nice screws here in the package. This is the, I'm going to start to assemble this together so you can see how it works. So first we can connect the port. Make sure to connect it in the right way. This is the power port. Then we can connect the DisplayPort cables. These are for cameras, DP cables. It's really nice and long. Now the other side. Right. Now I can connect these to the cameras. By the way, these casings are metal as well. It's really nice and high quality build. Right, it comes with another USB to USB-C cable, and this one actually, I'm not sure if everyone gets this. Maybe we got this because we are a special partner. I don't know. But this is handy. If you don't get this anyway, I really recommend it. It's very handy to connect multiple, like if you wanted to have a mouse and a keyboard or anything else. And here we have the power adapter. And oh, really handy again, a converter to the UK plug. Okay, so sorry, I connected this the wrong way. Okay, this is the way it should go. Let's power this up and see what we can see here. I really recommend first time connecting the Ethernet cable and the display, HDMI display as well. I'm just going to move the box out of the way for a second. Maybe I'll use it as a platform. Why not? Okay, let's do this. I have some tripods for these as well. I'll do them later. Okay, I have my Ethernet cable here. And I have a wireless mouse and USB keyboard. USB wireless mouse and keyboard. Very simple. Let's leave this here. And I have this portable display that I'm going to use to first initialize and set this up. This is working by just the HDMI cable and power. So I'm going to use this. You could use any display to power this up and do the initial configuration. Okay, let's connect the USB keyboard and mouse here as well. And the last thing, I will connect the display. Okay, I just now need to connect my adapter power to this socket. Okay, starting now. Bring the monitor closer so you can see what we're getting first time. Yes, JMO logo. See if I can move the camera slightly to the right. Okay. Cool. Here you can see the Western, oops. In fact, I really recommend that you get some tripods. These are the ones that I'm using. I don't know, this is quite random pick, so I'm not going to recommend. But yeah, I'll quickly mount these tripods. Okay, I got my tripods. I'm going to quickly mount these on 3 tripods. Oh, it's easier to mount them like this. Then after this, we're going to do initial setup to configure the SSH port to see how we can remotely access this. And then we're going to install Edge Impulse on this and quickly collect some data and train a model. Then you're gonna see how easy it is to finish the start to the end of the whole process of making a model and deploying it on the device using Edge Impulse. You're gonna see how easy and quick is this whole process. Okay. Let's put the last one here. Right, now the first thing you want to do is I'm going to try to sit my mouse is connected. Open a terminal window. Yes, so the first thing we want to do is to enable SSH. Let me see if I have connection to internet. If I do ifconfig command, In fact, I should see Ethernet address is assigned. So this means I have connection and I could ping Google to make sure. Another point about this unit is that this is running Ubuntu. Is running Ubuntu Linux, and you could actually see the release version. OS release, as you can see here, it is Ubuntu 20.04.3 LTS, and as you can see, it's Linux QCS6490 there as well. So this is the front end of this. The desktop is using Western Wayland. It is not the NOM that you might be used to it. Right, so let's go and configure the SSH for this. So you need to open this file. /etc/ssh/ssh dconfig. You open it with V, and then you need to go to the port section, press I to go to the edit mode, uncomment the port should be 22, and then listen address should be 0.0.0.0. This means you will have you will open this port to be SSH'd in from the whole network. Okay, so now press escape and WQ to save this, and that's it. So we should now be able to SSH this. Well, we need to also restart the SSH, or just do a reboot. System CTL. If you don't want to do a full reboot, you could do restart SSH, and that will restart your SSH agent. Another thing that I really recommend to do is just to, while you're here, just quickly set a password for this root account. It will make it easier for you when you're logging in. So I'm going to do passwd. That's the command to set the password. Just type a new password now and type it again. That's it. The rest of the things we could do later. Now just make sure you remember the IP address. Command again was if config. If you're connected with Ethernet, which is my recommendation, it will be ETH0. And then there you could see the IP address here for me is 192.168.0.148. That's it. That's all we need to do from this side, from the screen. Now that SSH is open, we could go to our main computer and SSH into the machine and do everything else there. So hello and welcome back. So here I have my terminal window SSH'd into the platform that you can see here in this screen. I'm just showing you the screen connected to the triple vision camera box, and as we talked before, from this screen we only need to get the enabled SSH and then get the IP address from here, and then the rest we could do it from our computers. In fact, I'm going to exit here and then we'll SSH back in, so you can see SSH root at the IP address. Obviously you need to be in the same network as this box to be able to SSH into it. The first time you do it, it will ask for a yes/no question. You type in yes, and then you get asked for a password that we set ourselves. So I'm going to type in the password, and I am in here. As you can see, let me make the screen a little bit larger. So after SSHing in, one thing that I really recommend you can do is to use VS Code SSH remote window for development. That makes things really, really easy and useful. So you just need to come here, click on connect to host, and put in your IP address and the username. So which was root at state 0150. Okay, that's it. This is what you expect to see. If I move this away, so you can see, you should actually see that VS Code will try to install VS Code server automatically on your board, and then you will automatically have an SSH window and also the file manager here, which is really helpful. You could try to yeah, I'm basically seeing the same stuff here. So I can do whatever I want, install things, copy files across, and do code development here. So I could start like a Python code and do whatever I want and execute it on the board. So all this development happens on the board directly, but I can use my VS Code on my machine. So the first thing you want to do after you log in is to set your time zone depending on where you are, just to make sure everything is in order, and then you can go ahead and install Edge Impulse CLI tool, and that's just one-liner command. You can find it in our documents, and this will download it, and then you need to do sh and execute this file to install it. It will take a little bit of time, but eventually it should just work. Okay, the installation is complete now, and we just need to source this profile. That's it. Now you should be able to have Edge Impulse Linux available in your tools. Okay, at this point, I want to make sure you all have an account on Edge Impulse. So if you don't have an account, you can just create an account for free. Just click on Get Started, and very quickly you can have a personal account. Any type of account would be fine to follow these instructions. Here I made a new project, fresh brand new project, to follow these instructions and show you how to do this integration. So, and also I've selected Qualcomm Dragonwing on the target just to make sure the profiling is going to be right for this target. So after you have an account, you need to run this command, simply Edge Impulse Linux, and then put your email address, and then password in. Then I have an authenticator set, so I need to give that code as well. Then boom, you should see the list of project, and you can search for the project you want to connect this board to. So I'm going to select this fresh project that I created, Codico demo, and my board should just recognize 3 cameras. This CLI tool automatically recognizes this board that it has 3 cameras. So it will give us an option of selecting whichever we want to connect to the platform, to the Edge Impulse platform. I'm going to select camera 0, and boom, you should automatically see this device appeared here. I will give it a name. You can give any name you want, and now either click on this link or go to the data acquisition, and you should see an option to select the cameras. So this is my camera 0. I'm going to see which one is it. Yes, so this is my camera feed. Just make sure you adjust the focus. Okay, this is better now. Now I can start taking some pictures of this pipe connection that I have. So you just need to, let's say I'm building an anomaly detection project. So you just need to label this no anomaly and start sampling it. It is asking us if you're making an anomaly detection project or not, and I'm going to say no. Sorry, it's object detection. This is not an object detection. We're building an anomaly detection. So as you can see, my pictures should just come here automatically. And you can just take more and more pictures and change the direction and orientation of this. Go ahead and take as many pictures as you want. This is an anomaly detection project, so I'm just taking pictures of good samples in my training set. So you only want to have no anomalies in your training set. Okay, I have another one here. I'll do pictures of another unit as well. Okay, and then you can, for the testing purpose, you can take some pictures of, well, I'll do more of training, probably try to aim for like 20, 30 pictures to start with to have something reasonable. So I'll take some anomaly pictures as well, just for testing. Remember, you don't need that for training. Okay, as you can see, the left screw is missing, the right hand side screw is missing. So I'll just take some pictures of that as an anomaly. Right, I'll do some more. I've collected some more data here to build an anomaly detection model. As you can see, in the training set, I only have good models, good data, with no anomaly. And in test set, I have some anomaly and no anomaly data. As you can see, now what I'm going to do, using Edge Impulse platform, you can easily build an anomaly detection model. The first step is to go to create an impulse. Impulse is essentially an AI model with multiple elements in there. So first I'm going to change the size to 320 by 320 to make the image a little bit larger and fit the longest axis here. And I'm going to select processing block of image. This will pass an image to learning block. And then I'm going to pick visual anomaly detection as a learning block. And that's it. Save the impulse. Next, let's go to the image section. We don't need to change anything here. If you wanted to change the color depth, you can do it and try that, but I'm going to leave everything as default here and generate some features. Okay, our feature generation is complete now, and in a few seconds we should see the feature explorer being populated by a diagram. Yes, so you can see the distribution of the features in the space. Obviously all no anomalies because that's how we train. Then you come here, we're going to use the EfficientNet and the patch core algorithm for anomaly detection. Leave everything as a default. I'm just going to add a 0 here to the sampling ratio because we increase the grid size to make this run a little bit faster. That's it. Now I can save and train. Okay, the training is complete now, and the performance metrics are going to be ready in a second. Before that, I wanted to go to the model testing section and try to classify all. Obviously, this is a very quick exercise to show you how to build the model. In the real use case, you would like to spend a little bit more time, use the Eon tuner, maybe have multiple experiments to try to really tune your models and tune your data collection process as well to collect higher quality pictures, get more pictures, more diverse pictures from different angles, different lighting conditions, different backgrounds as well. So it's all about like expanding on top of what we have right now. Okay, model testing is finished now, and we can see the accuracy score of 90%. And you can see some of the samples to see these are no anomaly. Oh, let me move this screen out of the way. You see no anomaly here. classified correctly, and some anomalies, yes, you can see classified correctly. This is missing the bolt. And these are classified wrongly. Yeah. Right. It's possible to avoid these by adding more data and improving your data set. Now, I wanted to quickly also show you the inference time. The metrics are ready now here as well. In the training section, you can see inference time and flash usage for this algorithm on Qualcomm Dragonwing QCS6490. Now, once we're happy with everything, we come to the deployment page. We have a variety of options to deploy this. What I'm going to show you is ARC64. This is the generic Linux executable and EIM file that bundles in the Edge Impulse SDK together with the model, and it has the pre-processing, everything together. This is one option. You could also try this one if you have Qualcomm neural network accelerator libraries available in your board. That's the topic for another conversation. You could either try to download these files from your browser and copy it over, or you could go to that board, use Edge Impulse Linux runner. There's another variant called runner. So you use this, and you could directly run it or use this to download. So you see multiple options. So I'm going to use the runner directly to run this. It's going to ask, I'm going to go ahead with unoptimized one for now to try. As you can see, this is trying to build and download the model. In the deployment page, you can see this deployment appeared here. Okay, it downloaded and it started running it. So it went quickly, so we couldn't see the link there. I'm going to try it again. Okay, I'll scroll up. You can see a link here. If you just click on this link, it will give you a web page, a local web page. It's if you pay attention, it's the IP address of your board, and is just showing the live stream of the camera with anomaly detection running on the machine, on the device, and you can see the inference time 4 milliseconds for each inference, and this is the live stream. So I'm gonna try to move as you can see, moving this back and forth. I'm gonna put another sample in there. This has no anomalies, as you can see, a perfect sample. And I'm gonna put again anomaly sample, turn it around. It's a very quick model, but it still works really, really well. Cool. So that is one thing I wanted to show. Another thing I wanted to show is how to download a model from here. So if you wanted to have the EIM file locally in our machine, which this was locally, but just have the file itself available in the directory, You just type download after this Linux runner and give it a path, formal AD, for example, .eim, and it should just download the model for you here, and it will store it in your local path. There we go. Or you could use the method I mentioned, the VS Code extension, to copy the files across if you have um, other models available you wanted to just copy in. In fact, I have a couple of other models I'm going to try to run and show you how it. Just drag and drop to this window, it should copy the files over. Yes, now I have two more classification, one more classification, and one more object detection models available here. Now, before we go ahead, I wanted to show you how to stream the cameras live on this screen, directly on the HDMI screen of on the board, because it might be useful for your project that you're trying to build. So in order to do that, first I want to set my environment. Because I'm SSH'd in, I need to make sure my terminal window, my SSH session, has the right environment variable. For that, I'm gonna copy paste. I'm gonna set these two environment variables. They're related to the Wayland display. It's just setting the display name so that it would present the screen in that display. That's one, and then another one exporting the Western config file, the path of the config file. So once you have this, you can now test if your screen is working and configured correctly. So I'm going to run a test command, test GStreamer pipeline, GStreamer launch video test source, and auto video sync. So this means it's going to launch a GStreamer command and take the video test, a random test source, and display it on the screen. If you pay attention to my screen here, you should see this test source appearing. Now the thing with Wayland is that it will always present the stream on the top left corner of the screen. Just remember that. But you can change the size and dimension of it. Next command, now that we know our screen works, let's test the camera. Now I'm going to use a camera source from Qualcomm Camera, and this element shows which camera do you want to use. I'm going to use the camera index 0, and then gonna display it in Wayland sync. So if you launch this command, you're gonna get live stream of the camera. This is actually super low latency. As you can see, it's very fast. You could also make this full screen if you wanted. I think the command was full screen equal true. Yes. So you can see this is now in full screen, again, live stream. Obviously you could do all sorts of things, stream multiple cameras at the same time using GStreamer pipelines. you could also run models on GStreamer using Edge Impulse GStreamer plugin. That's again another topic for another session. But now I want to show you how to run multiple models together at the same time on this board. In order to do that, I'm going to go back to the command I had, Edge Impulse Runner, and I'm going to add a port number. So that port number is basically says which port to use to display that web page. So let's use 1111 for the first one. This is going to bring up, oh sorry, this was the wrong command. It should just be this one, just the model file, FOMO AD, I think, yeah. And then the camera number, which was 0. Now this, we've seen this working before, so this is going to show the same web page as we saw before with the inference happening there. Oh, I changed the port, so this should be 1111. Yes, now this is live. Now I'm gonna open another another terminal. I want to display it horizontally. Okay. Let's leave that running and SSH in again to our board. And I had other models available here, classification. Now I want to run classification models. I'm going to use the same command that I used there, but then only change the camera index to 1. Model should be valve classification, and then the port number should change as well. Cool, this is now doing classification. I could see it in this link. Oh, it's out of focus, of course. So I'm gonna again split the screen again and SSH in and do the same thing for camera and do object detection. Okay, it's an object detection model running now. And we have, okay, I tried to run 3 different models and 3 different terminal windows here. And I configured each of them to use a different port. So you can now see 3 different models. The top one is presenting in port number 1111. It's an anomaly detection model. It is running live, as you can see. And then the second model and the third model, yes, third model here. It's a classification model. It's running here, again live. And then the second model is object detection model with bounding boxes. We have multiple object detection models available. This is the one with bounding boxes. And this is again running live. So from here, you could take this and do anything you want with your projects. Train different models, mix them, combine models, and hopefully build a project that suits you the best. Thank you very much for watching the video and hope you enjoyed it. And leave us a comment if you have any questions, or send us a message if you find a problem. Other than that, have a good day.